is Luissa Viruni, and I am doing the extra credit project for Social Science 10C. I will be explaining the post hoc test for a one-way ANOVA. Before we get started, I would like to say that you should always remember that rejecting the null hypothesis is an ANOVA, and the groups you compare are different in some way. So before I start explaining, let's imagine we ended up rejecting the null hypothesis. So the example that I'm going to be using is that I want to test a new anti-anxiety medication. I'm going to split participants into 3 conditions: 0 milligrams, 50 milligrams, and 100 milligrams. And then I'm going to ask them to rate their anxiety level on a scale of 1 to 10. However, I'm not going to be using real participants. I am just going to be making up numbers. We also want to know if there are any differences between the 3 conditions using alpha 0.05.
And we do that to see the 3 differences between those groups that I had mentioned before. So now that we rejected the null hypothesis, it's now the appropriate time to perform a post hoc.
Luissa and I thought it would be a good idea to use Snapchat and these filters to keep your attention during our video.
Hi, my name is Giron, and I am also in Social Science 10C. And now that Luissa has rejected the null, we can move on to a 2-key test and focus on examining the mean differences between 0 milligrams, 50 milligrams, and 100 milligrams. One of the many benefits of performing a 2-key test is that there's a greater chance for rejecting the null hypothesis, but also there's a greater chance of making a type 1 error. So let's move forward. In order to do that, we will be calculating the means of our groups. So for 0 milligrams, we will be adding and dividing by the population, and so forth with 50 and 100 milligrams. And as you can see, for 0 milligrams, we end up with 8.14, 50 milligrams, 6.71, 100 milligrams, 3.00, and then we move to calculate the HSD, which stands for honestly significant difference. Moved on to calculate HSD, we must find MS within as well as N. In order to find MS within, we use our ANOVA source table. And N is just the population for the individual groups. But also we need to find Q, a new statistic. In order to find Q, we use the Q table, and then we use the number of groups and the number of degrees of freedom within the error term. We found Q to be valued at 3.61. We put that into the equation to find our HSD. MS within, 0.57 over 7 the population. Square root that, and we got 1.03. 1.03 serves the measure of how far the individual groups can be apart in order for them to be considered different. Now that we've measured how far each mean is from the other mean, using 1.03 as the measure of what can be considered different, we come to find that each mean is completely different from one another.
Now that we've run our 2-key HSD test, we can confirm that rejecting the null hypothesis was the correct decision.